Well, so let me take the derivative of this, okay? So we've got 6x to the 4 times cosecant of x. There's nothing we can do but use the product rule. Y prime. So I'm going to do this, and I'm just going to use the prime notation this time just to, since I started. So if you want, you can use the prime notation for these, though, as I said, usually I don't. Right, so something like that. And then you go ahead and evaluate. So the derivative of cosecant is negative cosecant cotangent. So I left those up there so we have them. And then here the 6 just is going along for the ride there. So I guess I would just write this as 24. Right? I just like leave it that way. You can, of course, play with it a little more if you want, right? Because I could like pull stuff out, like I could pull out a 6x cubed cosecant x, and then I would end up with a negative x cotangent x plus 4. There's not like a huge reason to do that. You're fine, you can just leave it here. Of course, if I'm putting this expression into WebAssign, this one is maybe a little shorter. It will, by the way, it should take either one, by the way. Yeah. All right, so that's one example. Let's do another example. So that was one with the product rule. We should do one with the quotient rule, right? Sine x over 1 plus tangent of x. So dy dx now is, my bottom is 1 plus tangent x quantity squared, and then I have 1 plus tangent x times the derivative of sine minus sine times the derivative of 1 plus tangent. Okay, so what do we have here? 1 plus tangent of x quantity squared, and then I have 1 plus tangent, okay, derivative of sine is cosine, and then derivative of 1 is just 0, but derivative of tangent is secant squared. Yeah, so I would just leave it like that. I mean, you could, I don't know, like this tangent, like you could put it into sines and cosines, and then this cosine would cancel out there. But then you still have this. I mean, that's not going to go anywhere, so it's fine just to leave it like that. Oh, I did want to do, because I had forgotten to do this, another example of the product rule, but sort of a, now in this example, you have not 2 functions, you have 3 functions. But the idea is the same, right? You just have, each time you take a derivative of one of them and you're multiplying by the other 2. So of course you can do that, and you can do it in 2 steps, but you can just write it straight down. So you can multiply as many functions as you want, and you're just sort of repeatedly, it would be like this, right? So this it's cotangent, not cosine, okay? Plus, now I've got x, and I've got the derivative of the middle guy, and then I've got x, the x, and then I've got the derivative of the last guy. So you can go ahead and just do it straight like that. Okay, of course I could have started over so I wasn't so scrunched, but that's life. So the derivative of x is just 1, so this first one is just going to be e to the x cotangent x. The second one, of course, derivative of e to the x is just e to the x, so I end up with this same thing. And then my third one, the derivative of cotangent is negative cosecant squared. So this can be minus x e to the x cosecant squared of x. Okay, and then that is the derivative there. Of course, we can do one more example, which is going to be just another one of these tangent line problems, but I'm going to just remind you now, depending on what we're doing, right? So here I've got a pretty simple one, actually. Where was it? F of x equals what? 2 plus x plus sine x? No, x plus 2 sine x. Okay, and the question is find all points where the tangent line is horizontal. So basically we're taking the derivative and we're setting it equal to 0, right? So, this is easy to take the derivative of. We don't even need any, you know, fancy quotient rules or anything. The derivative of sine is cosine, so I have this. I set this equal to 0, and now I just solve for x, right? So I have 2 cosine x equals -1, and then cosine x equals -1/2. Okay, so what points are those? That's a unit circle point, right? Cosine is the x, so it would be, okay, no, not that one, right? This x, so it would be these two, right? So on my unit circle, then I would have x equals 2 pi over 3 and 4 pi over 3. Right? You know what? I would like to say find all x values, not points. Because these I can list, right? I want all of them. So not just 2 pi over 3, but every time I go around, so I can put like a 2k pi here or 2n pi, regardless, whatever you want. Okay, so I've got those. Okay. Now, why did I change it? Okay, because this is just the x value of the point. If it says find all points, typically they want the x and the y value. And I, of course, am always, for these, this function, the y value is going to be different, right? Because of the x, right? So a lot of them may not be the case, but in this case, it would be different. Each value of y is going to be different. You know what this is going to look like, something like this, right? Anyway, so yeah, so sometimes they will only ask for the x value.